Hello, everyone. My name is Greg Lee. I'm an assistant professor at Acadia University in Wolfville, Canada. This is a paper I co authored with a graduate student working in our department, Ajith, Kumar, Veera, Raghavan, and the CEO of Fundmetric, Mark Hobbs. And the title of the paper is Machine Learning the Donor Journey. So, in order to understand the paper, of course, you need to understand what the donor journey is. If you read the paper, we define it as the content and mediums of communication that a donor engages with prior to making a gift. So that's rather formal. So slightly less formal would be we're looking at what did the donor do, what actions did the donor take, but also what was done to the donor. Did we send them an email on the way to them giving a donation? So ultimately, we are trying to increase donations for charities. So, how can we learn what leads to a donation is a problem that charities face always. So, they're seeking ways to increase donations by learning about what actually gets somebody, not necessarily a previous donor, from where they are right now to giving a donation to the charity. And I want to state up front, none of this is trying to trick anybody. It's simply showing the donor what they actually care about or seeing how they like to be treated in order to continue to donate. So we talk about actions, what actions are done to the donor by the donor. The actions that we actually have in our data, so this is data from real charities, are in the table in the paper. The first one's not really an action; it's no action. But if you're looking at a set window size of say 6 actions, if the donor only took 3 and the charity had taken none, then you're going to end up with basically a filler action to say this nothing happened in the first 3 steps. The rest, though, are actions that actually do happen. So one is delivered. So we send an email. The charity sends an email to a constituent. So that actually gets to them. A different separate action, but obviously related, is the constituent actually opens the email. So just because an email is delivered to you, as you know, that does not mean you're going to open it. Then the next 3 there are negative actions. So if the donor complains or the email gets bounced or gets dropped along the way, then these are actions that are undesirable, but we do want to pay attention to them. Perhaps they can tell us that this person's not going to donate. And sorry, unsubscribed is there as well, similar bad action. Page view is a little hard to understand on the surface, but that means the person actually went to the donation portal, donated, they actually make a donation, and then clicked means they clicked on a link in the email or some donation amount. So they actually physically clicked. So we don't just look at actions that are taken by the donor or done to the donor, but we actually look at what emails were involved. So if you've paid attention to those previous actions, they all had to do with email except for no action. So these are the parameters that we started off with that we can change. We hope to expand this list, but how many words were in the email, how many paragraphs, how many images, right? So these first 3, just how does this email look to somebody reading it? Is it too wordy? Should this be split into more paragraphs? Are there HTML links, and if so, how many? How do you divide up your email into different blocks? So again, this is visual stuff. Then the rest is a bit technical, but it is something to consider. How many HTML content division elements there are, so just called divs by developers. How many variables there are. So when you get an email that says, Dear Greg, it actually says Dear F name, or first name. So how many of those are there in there? And then how many of those divs are actually editable and how many of them aren't? So these are just things that we can measure that we thought we'd experiment with. So if you look at a typical donor journey that could be successful, so these are journeys taken by actual donors to real charities. So you can see on the far left it says how many times this happened. So for a particular charity, 17 different people did this. They opened an email, they clicked a link probably, they went to page view, so they actually went to the page story, and then they were clicking around, and this led to a donation. For a different charity, performed more times, similar. They opened an email, then another email was delivered to them. Doesn't say they opened it right away. They actually ended up at the donation portal, clicked around, maybe opened that email that was just delivered and clicked to donate. So it's not obvious from the donor journeys we see by eyeballing it how well how to predict the typical donor journey. I don't have time to describe the deep learning we use, but recurrent neural networks are able to work with time series data, so data that comes in a sequence. That's an LSTM unit underneath. So this is a unit that can remember certain things and forget certain things along the way. I just honestly don't have time to describe it. So what does our data look like? The actions are one hot encoded, so there's a 1 in one of those gray blocks for each action. And then what we do is we append on the associated email features with each action. So if you open an email, well, what did that email look like? If you clicked on a link in it, what did that email look like? So a lot of these are going to be repeated because you opened and clicked on the same email. So these experiments were done with 3 charities. We just anonymized them here, but you can see their stats. So this was done on 3 different appeals where they sent out emails asking for donations, and those are in the paper. And we experimented with many RNN structures and ended up with those being the best for C1, C2, and C3. So the most important blocks here are the balance, training, and test error for C1, where we were able to estimate the RNN, recurrent neural network was able to predict how much somebody would donate within $25, which was our goal, was within 30. So what we needed to do with that was say, okay, now we've got an accurate enough model, we are going to ask it to predict, tell us what kind of email to send, how many words, how many paragraphs. So we couldn't consider all possibilities. So what we did is we took typical values that were used to get these donations. So those were the sets of words, paragraphs, and images we used within our experiments. The outcome of that was typically shorter emails were better for people who had already engaged, so people who had a longer series of actions, whereas people who had a lot of no actions actually the model suggested giving them longer emails. Now we want to test this in practice, of course, but our theory is that that people, the machine has learned that people who don't have as much information, no action, a lot of those need more information. So we believe that's what's happening. So we believe the models are sufficiently accurate to perform a case study, and we will. And we're currently working on varying the window size. So we looked at 6 actions, but why not look 1 action back? Why not look 15? Why not try different ones? Adding constituent features. So there's no features of the donor within that data. So we are going to add that. And examining how much, if you have a whole pile of no actions, does your accuracy go down? And ultimately, we'd like to predict major donors, so people who give large gifts. So if you have any questions, we would love to hear them. My email and Mark's email are there. So Fundmetric is a company that helps charities raise more money by making one-time donors into lifetime supporters. So the website is there. Our experiments were done with charities from Fundmetric, and if you'd like to learn more about them, you can talk to Mark or me, or visit the website. Thank you very much for listening. I really would love to hear your feedback.